Okay, next up for 6.6 is solving exponential equations. So before we could only do this if the bases match, and if the bases match, that's still the better way to go. So let's say we've got like 9 to the 2x equals 27 to the x plus 1. Okay, so if we had something like this, we did this back in 6.3, I think. If you can get the bases to match, that's still the better way to go. So I can rewrite these both base 3. Like that. And then exponent rules tell me to multiply. And this is, remember, you have to distribute this, 3x plus 3. And then our exponential rules tell us if the bases match, then the exponents have to be the same. So these two exponents have to be the same because it's 1 to 1. So we get 4x equals 3x plus 3. Solve for x. And we get that x is equal to 3. So 9 to the 6th is the same as 27 to the 4th. Yeah, that does work. Okay, so again, back in 6.3, this is when we learned if we can get the bases to match, that's the better way to go, and that is still true. All right, now, the ones in 6.6, though, all right, these, 5, 6, 7, these we cannot get the bases to match. So 2x minus 5 equals 9. Sorry, hold on one second. Okay. 2x minus 5 is equal to 9. I can't get the bases to match. 2 and 9 don't have common factors. So what I'm going to do is I need to take a logarithm. Now, the book, the textbook, MathLab, whatever you're looking at, they have you take log base 2 because it cancels with 2. Let me just show you how that works. So log base 2, 2 to the x minus 5 equals log base 2 of 9. Okay, so the log base 2 and the 2 cancel. We get x minus 5 equals log base 2 of 9, and then we add 5 to both sides. And keep in mind that only the 9 is in the logarithm. This 5 is on the outside, like this. All right, now this method works fine if you have a calculator that can do this, okay? Or if you do change a base that we learned in the last section, and make this log 9 over log 2 or ln 9 over ln 2. But the problem with this solution right here is it's a little bit hard to get into a calculator. Okay, you have to have a calculator that can do that. Not even all the graphing calculators can do that. So the generally preferred solution is to change everything into natural logs. So when you get into these problems and you've got like different types of logarithms going on and things start getting really complicated, natural log and common log are kind of like the common denominator, and you can just change everything to a natural log and go from there. So generally when they get more complicated, that's what you're going to do anyway. So I think that's the better way to go. It doesn't matter which way you do it to me, as long as you can get your answer into a calculator and get a decimal. Okay, that's the key part there. So let's look at what it looks like if we take a natural log on both sides. All right, so we take a natural log on both sides, and it looks like this. Now, natural log's not going to cancel with anything, but remember our properties, we can bring the x minus 5 down to the front now. Oops. Okay, so we can bring the x minus 5 down to the front. I'm trying to get x by itself, and these are all just numbers. It looks messy, but they're just numbers. So I'm going to go ahead and distribute. There's two different ways that you can do this. You can divide the ln 2 and then add 5, or you can distribute and then move things around. It comes out to the same decimal. Again, you're going to have to get to a decimal for these answers. It comes down to the same decimal, so whichever way you prefer is fine with me. But the ln's are easier to get in the calculator. Okay, so I'm trying to get x by itself. So I'm going to move this to the other side. And then I'm going to divide by ln 2. And let me see what that is as a decimal, just to make sure that everybody can get it. Whichever way you do it, you've got to make sure that you can get this as a decimal. Sorry, I hit a wrong button. Okay, it looks like that's equal to 8.17 when I round. Okay, All right, so whatever version you use to solve this, you should be able to get down to the decimal 8.17. All right, let's try another one. And I'm just going to use the ln method. If you like the log method better, you can do that. You can see that in the book, and that's how they do the homework helps and stuff. All right, next one. E to the 2x plus 5 plus 3 equals 15. Okay, so this one we're going to take an ln either way, because if you do the logarithm that that cancels out, it's going to be natural log. So either method, you're going to take an ln. But first, we don't want to take an ln right here, because remember, we got to do the whole side. Again, you can't take logs, exponentials, any of these things term by term. So it's got to be the whole left-hand side, the whole right-hand side. So the first thing we've got to do is get the exponential by itself. Okay, and now we can take a natural log on both sides. Natural log and e cancel out this time. Okay, so we don't have to bring the exponent down because they cancel out. We've got 2x plus 5 equals ln 12. All right, this is just a number. This is a number. This is a number. We're just trying to get x by itself, so we're going to do minus 5. And I'm going to write this as minus 5 plus ln 12, just so we don't get confused on order of operations here. And then divide the whole thing by 2. Okay, so we're going to get negative, whoa, sorry, my pen went a little crazy. Negative 5 plus ln 12 over 2, and let me see what that is as a decimal. Okay, I get negative 1.26. Negative 1.26 when I round that. All right, please make sure that you can get these into your calculator. It's a big deal. Okay, you might just think, duh, you just plug it in, but it's a little bit tricky. So make sure that you can get these in the calculator. All right, and then the last one that we're going to do, number 7, is 3 to the 2x equals 2 to the x minus 3. All right, now this one's a little bit different from the other two because you've got exponentials on both sides. Okay, so exponentials on both sides. So again, I'm going to take natural log on both sides. It won't cancel with them, but it'll give us something that we can, that we can work with. I lost my 2 here. There we go. Okay, so ln and 3, ln 2 don't cancel, but now I can bring the exponent down to the front. That's the key here. And I get 2x ln 3, and I get x minus 3 ln 2. Okay, so bring those down to the front. I'm trying to get x by itself. We've got a couple x's here. The rest are just numbers. It looks pretty messy, but they're just numbers. So we've got 2x ln 3. Let's go ahead and distribute this because we've got to get the x's together. X ln 2 minus 3 ln 2. Okay, so just like any other equation, you want to get the x's on one side, numbers by themselves on the other side. So let's move this over. And we've got 2x ln 3 minus x ln 2 equals negative 3 ln 2. All right, now we've got the x's on one side, but the problem here is that we can't put them together because they're not like terms. You can't put natural log of 3 and natural log of 2 together. So if they were both the same, like natural log of 5, natural log of 5, then you could do it, but we can't put this together. So you may remember this trick from other things, like you may have seen it with square roots and stuff. If you can't put two numbers together, and you're trying to get x by itself, the trick here is to factor it out. You've got a common factor of x. You can't put them together, but you can take it out. And then you're left with 2 ln 3 minus ln 2. Okay, and these are all just numbers. You can put them in your calculator, they're decimals. So now I want to get x by itself. The opposite would be divide by 2 ln 3 minus ln 2. Divide by 2 ln 3 minus ln 2. All that cancels. Okay, now this one especially, this can be a little bit tricky to get in the calculator. The way that I'm going to put it in is I'm going to put in negative 3 ln 2. Your calculator's probably going to put parentheses around that. Okay, and then divide by, actually here, let me put it over here. Negative 3 ln 2. divide by, and anytime you have more than one thing going on in a fraction, you have to put parentheses around that. So I've got to put parentheses to force all of this into the denominator. So 2 ln 3, it's going to put parentheses around that, minus ln 2, and then close the whole denominator. That's what it's going to look like when it's going in the calculator. Hold on. 2 ln 3 minus ln 2. Okay, and I get negative 1.38. All right, holler at me if you don't get those decimals right. It's possible I put it in wrong. No, that one looks good. That one looks good, so you should get that one. But again, make sure that you can get these in the calculator. You need to be able to get this form, and you need to be able to get the decimal form. Okay?